hopefully you're in the right place. This is reactive programming using observables. You did hear that correct. We had a talk right before me talking about reactive programming with RxJS. Just replace a couple of words and you have some similar stuff. But I will be talking about some different things from what James just talked about previously. If you were in here before, hopefully you'll gain some additional information about this really important topic. Just briefly about myself, my name's Jeremy Lund. You can follow me on Twitter at Jeremy_Lund. My code examples shortly after this conference will be up on GitHub in my GitHub account. It's London, that's a 0 there in the middle. That gets confusing sometimes. Anyway, let's get into the topic. First of all, what is an observable? So an observable is nothing more than having something called an observable that can be observed by something called an observer. And the way that it's connected is through a subscription channel, and it pumps values from the observable to the observer. You may have heard of other things before in our code, loops with arrays and other things, and go, well, why is this different from why are observables different from arrays? We have these values coming through and can be observed. Well, this one is the direction in which the data is being pushed. If you think about it like a stream, we're pushing the data from the observable to the observer. Most of the time, it's the other way around. When we iterate through an array, when we use something like a for each loop or a for loop, we are pulling data from that array to ourselves, where this is saying, I'm interested in the data that's in this observable, I'm going to push it to me. These marbles here, who's seen marble diagrams before or heard of marble diagrams before? It's just a simple representation of representing that this is many values coming from this observable over time. It could be synchronous and it can also be asynchronous, as we'll look at momentarily. There's also this little line here that represents a completion. One of the things that observables have over other asynchronous-based programming is it has an indicator of completion. An observable can tell it, I'm done sending values to you. You can also combine observables together to also indicate that as well. So let's look at a simple demo to show us how this works. So over here on the left, I have a aptly titled base demo. Can you see in the back okay? Size? Okay. So basic demo, hello world. Doesn't look very interesting right there, but let's see what's actually going on. So, oops, hit the wrong key there. Basic. Actually, let's full screen this for a minute. Here, is the font size okay in the back? Okay. So we're importing the observable from the React.js library. I am using React.js, RxJS 5 for this demo. Observables is a spec and it's a proposal out there, and I'll talk about that in a few minutes. But the best library right now as far as following the spec is RxJS 5, and they're planning to keep that compliant. So I'm using that here. I've got some simple helper functions that are kind of out of our way here. But really, all I'm doing is I create an observable. This is one way to do it, is with a constructor that accepts an observer, and then we pump values to it. At subscription time, that's how the observer gets attached to this observable. But all we've got is a simple API here. Notice these are just very simple functions talking about interacting one object to another or one function to another. And we have this very simple API. There's 3 functions that are provided on this observer interface. The next function, the complete function, and the error function. So right now we're saying we're going to push 2 values onto this observable stream. The first one's hello, the second one's world, and then we're going to indicate completion. And then we're subscribing right now to those values. And again, if I reload this, no magic there, it's just showing the values on the screen. If we added an additional value here, or if we even just changed it, exclamation point, and I turn live reload on, which will help show that, then we have that value here too. We can change this to add a second value here. We'll just say, let's just add UtahJS here as well. And it's adding that value on here. What you're not seeing here is it's just using rollup in the background with a quick live reload, so nothing too big there. And it's also indicating completion, which is really important. It knows not to listen for anything else. That's the contract that the observable has. There's also additional values we can add to the subscribe. This subscription here with the value is implicitly saying I want to listen to anything that's pushed on the next when that next is called. But I can also add additional functions here. The second function in the chain is error. So we could just do an append to, let's see, I've got an appender here, and we'll just say error. We'll do error.message or error. Just on the end there, let me full screen that for a second. So that's our second function. The last one can indicate completion. So we can listen to that event as well. And we'll just append out complete. So we can listen to all three of those. I'm not going to worry about indenting right now. So let's see here. Let's just save that. And you can see it wrote out one more value, complete, when the completion happened. Just to show there's no monkey business going on here, let me just take that appender out on the first one, and you can see it's showing the values in there. How that error one works, so this is really cool about this versus some of the other asynchronous things. Not only can we see when things are completed, but we can also have errors kill the chain as well. So let's put an error right in the middle, right after hello world. And we'll use the error function rather than the next function, and we'll just say error because I'm feeling really creative right now. We'll just put that right in the middle. You can see it stopped the chain right there in the error. Usually in a real application, we wouldn't be logging error out to the screen. We would be logging it with red letters around it and a big stop sign, of course, with it, right? No, we'd actually be handling some other stuff internally. But we can handle those errors. There's another syntax for this subscribe to. If you don't want to either subscribe to all three methods, or if you just want to be more explicit about this, this is equivalent to basically, not to hello, to subscribe, where you can actually give it an object instead of functions that are, of course, named the same way, where you would have your value here coming into a function. You would have a error one and a complete. I won't complete those, but you can see those are the keys there. Those are the values. So maybe you're only interested in just the complete. You could omit the other two and just handle those ones. So there's some different syntax there too. You might be asking yourself, well, you haven't shown anything asynchronous here. You're showing these values. And that's true. Observers just define an interface between a observable and an observer. And they have clear syntax and clear semantics in between. Once you have that, you can do all sorts of cool things with it. So let's clean this up for a second here. One thing that we can do with this is we can make it asynchronous, even just with the foundational method. We can just put a set timeout in here and just say after a second, we want to write out one of these methods here. So let's just move that down here into the function. And you see after a little bit longer, because I probably did something wrong. Let me see here. Oh, you know what? This is the funny thing there. I actually have my complete outside the block. So what it did is it went through, it did next, because this is done after complete. The contract is as soon as you call complete, no more values are coming in. So in order to actually have this work, I would need the complete in there as well. Hello, and then world comes in a second later. And that's important to know too. You can do this. And the same thing happens with running complete and it's done before this happens and nothing happening later. The same thing happens with errors. An error happens and your stream is complete. So that's just some real basics of what the observer interface works with. Fortunately, with RxJS 5, it also provides some additional factory or creation functions that allows us to wrap all sorts of different objects. So let's look at some of those. Let's see here. If I can find my presentation. All right. So the first things we learn is an observable can be async, but it's not required to be so. Oftentimes people talk about it sending values over time. It can send many values at once. It can be used for synchronous as well as asynchronous. Also, an important point with these is they're dormant until they're subscribed to. That's an important point as well. James pointed that out in the last presentation. If you don't ever subscribe to an observable, it never actually writes anything out, which is really cool because you can put those together into a library and then you can attach to the ones that you're interested in using in there as well. Well, Jeremy, we have this other wonderful thing that delivers stuff over time. It's called promises. They're amazing. That's why I included 3 distinct explosions on the slide to show how amazing they are. I love promises. I love that they're in the core browser spec now, and we can use them almost totally without polyfills or other libraries. They're great. But the important thing with promises is they only can return one value. Well, what do you mean, Jeremy? I return arrays, objects, all sorts of wonderful things with promises all the time. Yeah, but they're all still in one object, returned at one time. That's part of the benefit of the promise API. It returns one thing. When it's resolved, it's done, and it returns that individual value. And you can even cache that reference to that promise anywhere in your application. And if you ask for it again or use it, chain it to a then clause or something, it's still going to return you that same value without having executed again. So that's really important. And it also has a place where it marks completion. So promises are valuable, but please understand that observables are something that provides a different solution there. If you needed to do in your application, call the same HTTP service multiple times over and over again over time, as we ought to do. I mean, we have all sorts of interactions on our page. Promises may be, they're a little bit lower, or they may not be as good of a fit as observables can be in our applications in that case. And this is the way that you would actually adapt a promise in the observable API to be an observable. And that's what's awesome about it, is you can actually put an adaptive layer on these and use them as observables. So you can wrap just about anything. Here's events. Events are another asynchronous thing we use in our applications. We have this series of click events that may happen over time. We can adapt an event, take an element, and in this case a click event, and we can record when those clicks happen over time and record those mouse events, or those click events. We can also take intervals as well. If you've created an interval and then you're trying to keep a hold of that handle somewhere in your code base so you can then cancel it when the time comes, observables are a great way to wrap those up. Because, again, they have that clear contract of when you can subscribe to them, when you can unsubscribe to them, and when they're marked as completed. Who's heard of duck punching before? Heard the term duck punching? It kind of sounds violent, but it's not really that. Duck punching it comes back to object-oriented design a long, long time ago, and they talk about things that follow the same interface or contract. If it walks like a duck, if it acts like a duck, if it talks like a duck, then it's a duck. Well, with these adapters, we can take these different ducks. I'm a promise, I'm an interval, I'm a click event, I'm a callback, I'm an observable. This one's the real one down here, but they're all adapted into this interface. Duck punching is the idea of taking something that's of one type and adapting it to something else so you can use it. So we can take all these different items, as I talked about before, and convince them, not punch them, but convince them through adapters to be something different than what they are. That's the concept of duck punching. Why on earth would we want to punch ducks or talk about that? Well, it's because of all the wonderful operators that are provided with observables and what that does for us. Once we adapt all our asynchronous events and synchronous into the same API and the same contract, we can also do all sorts of wonderful things in combining them together. Who works with just mouse events on their own when they're developing a web application? Just mouse events. That's it. Who works with input fields as well? So mouse events and input fields. What about working with backend data, calling REST APIs? Do you do that as well? We think of those as 3 separate things, but really they can all be the exact same thing, and we can work with them together. That's where transforms come in. So this is an example of what's called a marble diagram, which is showing the way that an observable stream pushes data over time from the left to the right there, these different values. The one below is the result of the operation. So in this case, we have a map function that's going over all of the values, and that's simply transforming the values that it receives and moving them along. We can also combine multiple streams together. There's operations like the merge operator where we can combine them together into one single stream. You can imagine, and we'll do this momentarily, taking a click event coupled with maybe a keyboard arrow event and combining those, merging those events into one and treating them the same. We sometimes have to do that. You know, you maybe got a directional control on the screen as well as an arrow, and you want to have them have the same behavior. You could merge those event streams together and have them do the same thing downstream without repeating code. And of course, I talked earlier about this. They can be synchronous as well. They don't have to be asynchronous. This is actually using Extreme syntax at the moment. I forgot to change that. But you can send, this is what my hello world was doing earlier, where it's basically sending all the values at the same time and then marking it as complete. And more of these you can look at, more of these different diagrams and how these operators work at rxmarbles.com. It's actually really cool because it has an interactive diagram where you can slide the timeline and see in each marble and see how the operators change as you adjust that. So let's talk about TC39. So when we talk about observables, I've had some people ask me, oh, is that in ES6? Is that in ES7? Is that even a thing? The status right now is it's in stage 1, which is the proposal. It's been sent about a year or so ago to the TC39 thing, and it's still technically in stage 1, although they're working on a draft right now to get it to stage 2, and they're trying to get it moved along there. The nice thing is most features that make it to stage 2 in this make it eventually into the language. The fortunate thing for us developers is we have plenty of libraries out there that implement these observables so we can use them today, which is fantastic. So let's go back to the editor and look at a couple other demos. And let's see what time I'm at. Oh, I got enough time for a couple demos. All right. So let's look at this one here. This is a clock. It's an amazing clock because it starts at whatever time I decide to start it at, and it counts the number of seconds since I've been talking. I've been talking a long time here. Let's see. Let's change the code here. So what if the spec was that our manager came to us and we actually want a current time on the clock? Well, let's use some of these operators to do that. You can see here, real simple, we've got an interval that's incrementing every second. The way interval works is it starts with 0, and every second it's transmitting the next value up the chain. And then we're subscribing to that and just writing it out to the page. Hence the awesome just seconds there. If we wanted to change this, what operator could we use to do it? Well, I just wrote it. Why did I do that? I get talking and typing at the same time, I forget. There's a big hint on the page, if you're wondering. We'll use the map operator to track it down. And let's just say our manager wants to keep it like working in every locale or whatever, but they really don't care how we present it. So we could just change that to date now and cheat. All right, so right now that's, I'm going to guess, 2:49 p.m. and 33 seconds or something. I don't know. But it shows how it changes there, and we could transform, and actually, you could pipe this into, say, Moment or something else like that and get it into a nice format, internationalized for your joy and convenience, because your manager probably would give you a weird look if you came to him with this and said, I did it. I've got the current time out there right now in seconds. It's great. All right. So let's look at a different demo, a little more interesting than a ticking clock. A counter. Counters are great. Let's look at this one instead. So this one, we can click the buttons here. We can increment it by 1. We can decrement it. Fantastic. I've never actually implemented one of those in a website, but they're fun to demo, and we're going to be able to look at some cool principles by doing this. Let's look at our counter one here. So here we've just got our, let's actually look at the markup. Actually, we don't need to look at the markup. So we've got our increment button and our decrement. This is just shortcut for query selector, just to get those elements. And we have the value that we're going to display. So we can see here that we're listening to 2 events. We're listening to the click event on the increment button and the click event on the decrement button. And then we're mapping that to a value. Just because, this is a really important thing with map and these other transformers, just because we're getting a value down the stream doesn't mean we actually have to use it for anything. In my last example, for instance, I was using date.now instead of the value that was coming in. I don't necessarily have to use the value, but you can. This one I'm just mapping all the increment clicks to a 1, all the decrement clicks to -1, and then I'm merging those streams together. If you looked at the stream at this point, you would have, if you had, let's say, you had clicks from the increment button. You had some clicks here and clicks going down there. And then let's say this is your decrement button. You have click. If this is our marble diagram, whoops, it's trying to be helpful. Then our resulting one is we're getting out of this stream, this is turning into -1, which happens to be conveniently a dash. This one, that's brilliant. All right. You should think this through. All right. But those are ones. These ones down here are going to be -1s. Just pretend that there's a negative. It's actually kind of red right now, so that's really a negative. But those are going to be negatives. Then when we merge this together, we're going to end up with a stream that has -1. Just pretend that's a -1. This is a real one. And this is a -1. But we get all those little deltas coming through. And once we get the deltas, we can aggregate them together. In arrays, we normally use the reduce operator. But we don't really want to wait to show our count until we unsubscribe from our thing, because that would take a really long time to see the count. Most of the time with the reduce function, you need all the values up front. It iterates through all of them and gives you a result at the end. With this, we want a running total, and running total is great for us right now. So we have a function called scan. And scan gives us the total and the delta, and we can just add those together. To start this out with a number, you can use the start with operator, and I've got it starting with 0. We could start it at 10. Maybe we're optimistic, so it starts with 10 instead. We can increment that through. One thing that we can also do here is we can listen to multiple events. So let's take, you can see I conveniently put these codes up here so I could remember them. So let's do up increments it by 5. We can merge that in, sure, why not? From events, and we'll just do off the document. We'll listen to the key down button. And we'll map that. Actually, we're going to take a little bit different because key down gives us all our keys, right? So we should probably do a filter on this instead. And we can filter event. Is it key code? Help me out. Anybody know? I think it's key code. We'll find out really quick when it works or doesn't. And then we'll map that to a +5. We'll increment it by 5 when it's an up. So let's just add that into our merge here. And that's just as simple as merging it in the stream here. So we can say, hey, when we have up events, add 5, clicks represent 1, clicks to our decrement equal -1. Let's take a look and hopefully this works. And I did something wrong, I think. Oh, you know what? That's terrible. It might be, I'm trying to remember. Haha, there we go. There's a few of them on there, but one of them is the key code. So key code worked. We're incrementing by 5. And you'll have to trust me. If I make my hand bigger, maybe you can see the click. But it's clicking on there. But you can see how this is really cool, too. One of the things I like with the interactions here is I can combine all my interactions with a form or with a component all in one place and say, here's the things I want it to do. And then you can imagine maybe having a service layer or something later on down here that actually takes that data that you've merged together and does operations on it. And that's actually, I did a presentation last month on a framework called CycleJS. Who's heard of CycleJS before? Anyone? Okay, so we got about half a dozen of you. That framework, if you really like observables and you really like RxJS, that one is based totally on this concept of working with observable streams. And it's fantastic. It takes a little bit of getting used to, and I'm still figuring out how to do certain things in it, but it's great. I think that's the last demo I'm going to be able to show. This 25 minutes goes really fast. Let me go back to my slide deck. By the way, I'll have all the rest of my demos out in my GitHub repo, again, that I mentioned earlier, so you'll be able to look at those. Just as far as resources, rxmarbles.com, very interactive way to play with the different operators. Front-End Masters has some excellent presentations on asynchronous programming. Jafar Hussein's stuff is great. They have a speed thing on there where you can adjust the speed of how fast they talk. I suggest with Jafar you keep it at the 1.0 or slower. He talks even faster than I do. But his stuff is great and he's sharp. Learn RxJS website, going to learnrxjs.io. This was actually built by a guy every day putting out a gist about one of the RxJS operators just to learn about how they work. And he's taken that knowledge together and put it together in a really great reference that teaches you examples, shows how the operators work. And then finally, the RxJS lessons on egghead.io. There's a ton of them out there. It's a great service, and I would use that as well. Credits for my slide template and the images that I use. I'll just show that for a second here. And Thanks very much. Again, follow me on Jeremy Lund or follow my GitHub repo. Thank you.